Okay, our next step in step 2 is to now study the approximate movement of the mechanism. And so what you're going to see in the overview document is that there is another direct relationship between the change in length of your spring, all right, which is equal to R times your theta, all right? And your theta is equal to the angular movement of the shutter here. So we've got our shutter here, and so that's this curved movement of the shutter itself, okay? Thinking about that curved movement, all right? And our R is actually this distance between the point in which the shutter arm connects to the housing, all right, and the point in which the spring attaches. So you'll see in the overview document that there's a little drawing here where you've got this value of R, all right? This is the point where the shutter connects. And this is the point where the spring connects. Okay. All right, so we've got those 2 points, and then from this point you'll actually have your spring, all right, and there will be some force that will be applied to that spring. Okay. So in order to determine our angular movement, all right, we'll need to know what that change in the length of the spring is. And so again, using a good old caliper, all right, what you'll want to do is actually measure the change in length of the spring from the open to the closed position. So again, we've got our housing here, so we're measuring it in the open position. You want to measure the length from here to here, all right, be consistent where you measure on the spring, and then in the closed position, all right, and again, you're measuring from here to here. All right, so it's a small change, all right, but you'll be able to determine that change. And using that measurement, all right, that's what you'll put in for your delta x right here. Okay. We know our value of R, it's provided to you, but you can measure it again, just looking at the housing here. All right, that's that distance from this point right here, all right, to this point right here. All right, so we've got our 2 points where the spring and the, again, drawn here. All right, so we know this is a known right here. And what we can do is solve for our theta. So of course, just some simple algebra here, that theta is actually equal to our delta x divided by our r. Okay. Using this equation, you can actually determine what that angular movement is, noting that if you keep everything in SI units, your corresponding value will be in radians, and you'll see that the question is actually asking for you to record your value in both radians and degrees. All right, so make sure that you do that conversion for step 2.